भी आप लोगों के पास क्वेश्चन हो तो हमारे मौजूद मेहमान यहाँ खड़े हैं, वो आपके सवाल का जवाब दे सकते हैं। माइक हमारे ऑडियंस में मौजूद है। आप लोगों से गुजारिश है जहाँ पे क्वेश्चन पूछना है तो प्लीज रेज योर हैंड और बेटे उत्तर दीजिए। सर प्लीज कम over.
Sir, my name is Mohammad Madani, lecturer Institute of Health Sciences. I have a question for you that how we can apply at a large scale such techniques, and do you have evaluated its economic threshold level and its application on such a large scale to benefit from such techniques?
Okay, so make sure I get the question right. For me, so far it's applicable or practical to use this kind of chemical on the practical use. Is that right? I'm sorry, is that right? Did I repeat the question right? Okay, just pretend it's right. Okay, so what happened is it's very costly if you synthesize a small RNA. So I didn't want to confuse you. So actually in some slide I used dsRNA, means double-strand RNA, which going to be converted into microRNA and to be equivalent functional. Okay, and for double-strand RNA, so far for us it's kind of workable because we can put the plasmid into bacteria and we can produce it by fermentation, and in some practices, and also there are patents already available, means you don't have to do a tedious purification of the double-strand RNA. You just break down the cells and do a very raw extraction, apply it to the field, and it will be pretty good. And again, like I said, okay, even it's kind of expensive, but if we use some specific top subject, like we have flowers, which is highly valuable, like a very delicious or very high-priced fruits. Like in our region, we are trying to use it on strawberry, and it's I would say it's doable. Thank you. I'm not sure whether I addressed the question right.
Thank you, sir.
I'm Dr. Tarek from University of Punch. My question is that RNAs are very much unstable in the environment.
Yeah.
And when we deal with magnetotheorizing, there is high temperature and sunlight.
Yeah.
In the presence of sunlight, how we utilize these RNAs, which are very much unstable, and we can bring up the problem.
Okay. Yeah, that's it. I have been challenged by this question quite often, and so I agree with you that RNA is very, very unstable, which in my aspect is a good part, because if we want to make it stable, then we have ways. Okay, as you know, this year's Nobel Prize of Biology was awarded to a couple who did a significant work on modification of RNA structures to make it more stable. Obviously, that is one aspect. Also, in my talk, I didn't specify the LDH, which is nanomaterial. Okay, that one can significantly increase the stability of RNA. So, in that term, I kind of can control the stability of double-strand RNA if I want to be short-lived. So I don't want to stay longer by safety reason, then I can use less modification and less nanoparticles. Okay, and if I want to make it stay longer, like in this case in ResPad, then I'm going to use modifications plus nanoparticles and maybe some other techniques. So That I address, and I do believe and agree with you. Currently, this one is not practical for rice. Although we did the research, okay, we had a demo showing it work, okay, theoretically, and a long way is go to that. Thank you.
Hi sir, my name is Mohammed Yusuf and I'm a lecturer in government postgraduate college. Sir, I have noticed a slide that was about both of this scenario you have applied mRNA on the date where the both of this scenario was known. So, sir, how can that be possible? Like that, you have taken mRNA from a plant and then you applied on the patent date of where the both of this scenario was known, and then it reduced actually the growth